When you want to make concrete, when you want to make make your mix there, it contains cement and sand, and different proportions of cement and sand will make different desired concrete. So it turns out for this question is a tough mixing question that involves the mixing of concrete. Now, let me say it as a little story. Let's say that you go to your supply area, and you have concrete that has 5% cement and 8% sand composition. And you're like, no, I don't need that. I need my concrete mixture to be 12% cement and 15% sand. So then what do? Well, you go look in your locker and you're like, oh, okay, we got 255 pounds of cement. So we'll dump that cement in there, and now we have an increased percentage of cement composition. And we're going to toss in some sand. But we don't know how much sand to add. So the question is this: how many pounds of the original mixture and how many pounds of sand must you add to the 255 pounds of cement so that you get this new concrete mixture that is the desired proportions of cement and sand? This question, if you're curious, I basically, to make the question, I went on Reddit and I Googled the worst possible mixing question, civil engineering, something like that. That's what I Googled. I mean, don't quote me on that, but I did it last summer and I was like, okay. And someone had posted this, and the whole feed was like, they were like in Pythagorean fist fights about what the answer was. So anyway, I'm gonna go through this one because it's a nice question, and also because it's tricky. So hopefully you enjoy it, and then we'll do the quiz after. So let's start with some let statements. By the way, this solution will be posted on Blackboard. And another thing I should say is that because your midterm will consist of smaller questions, this question most likely would not be a midterm question because it's just way too hard for to be a short question. I'm not saying you can't do it. I'm just saying it'd be annoying. So let's start with some let statements. So that's what we're working with. We have the concrete mixture, and then we have the amount of sand, and those two quantities are x and y because we don't know how much of each we need to add. So what we want to do now is we need to set up some equations so that we can solve for the values of x and y. So, question to you guys: how many equations, how many independent, so to speak, equations do we need to set up? How many equations do we need to solve this question? That is correct, Ethan. Good job. Because we have two variables, we want two equations. That's why this question ultimately will be a 2x2 system. All right, Amir. This one here is going to take a lot of reading over. I understand that. What you want to do is you have to think of it as concentrations, okay? So you have some stuff that is 5% cement and 8% sand, and you want to add some cement and sand so that the mixture that you have increases to 12% cement and 15% sand. So that means you have to add some sand and you have to add some cement to it to get to that new percentage level. I guess the main thing is if you understand the nature of concrete kind of behind. Yeah. Matthew is on point, I think. Oh, is it 25? What? Did I type something wrong? Matthew, I'm not sure what your comment is about. Okay. No worries. We're gonna continue, guys, because I want to make sure we finish this in a reasonable time. It's okay. No, that's a good thing you said you mixed it up. Literally, you're mixing stuff up. So even if you like, rhetorically speaking, it's kind of funny. Okay. Let's talk about the content. So the original concrete mixture, how much cement does it have? I gotta make a table for this, guys. Table's probably better, so I'm gonna make a table. Sorry, guys, I'm gonna a little bit quicker here. I think this should work. We'll do this one up nice. We're gonna go by weight, or in this case, mass or weight, because pounds is mass and weight. So we'll say here component. I'll just say your item, and then we'll say amount of concrete, no, amount of cement, amount of sand. I didn't use a table in the solutions, but I think a table is pretty cool here. So we have the original mixture. Some of these numbers are ridiculous, but it's hilarious that we're doing it. Okay, in the original mixture, which is 5% cement, that means that this would be 5% X, and the sand would be 8% X. If you want to make that a decimal, and you can make that a decimal. Now you're adding, this is amount of cement in pounds. Okay, sand added in pounds. Now if you're adding sand, the sand that you add contains no cement in it because you're just plain sand, and Y pounds of sand. Okay, so if you're adding cement, it is 255 pounds of cement, and there's no sand contained in it. Let's make a total here. Total cement is 0.05x plus 255. And this would be 0. And here, actually, I can put the total as well. So the total amount would be x plus y plus 255. So these are the numbers that I care about. If you understood those numbers, that's the key to the question. I answered this question in a profoundly different way on Blackboard. I did it through a series of let statements and with sentences describing the process. Here I'm trying to do it in a more visual way with a table. That way you have two different ways of looking at it. So hopefully this approach is more favorable to you. And if you want a more traditional algebraic kind of with sentences way that I did, you can see Blackboard later for that. Anyway, we're almost able to set up a system now because we know that our final batch, which has a total mass of this is our total mass. This is the total mass. Then we can use that to our advantage because we can get a percentage. See, in the final batch, it's 12% cement. So we can say that our final batch is 12%. What does that mean in terms of math? It means that if I take this number here and I divide by, whoops, I'll just type it out. If you take that number there, that expression I should say, and you divide by the total, that should equal 12%. And you can repeat that process again for the other one. And that's it, everybody. That's your system. That's the system, guys. So once you have those two equations in place, you can solve for x and y. I'll show you some of the steps for the algebra now, but eventually what you see here is going to look like a linear system. It's going to look just like the stuff that we did with Cramer's rule up and down the page for the past hour and a half. So I've probably scared a few people at this point, but this isn't necessarily something that we can gloss over anyway. So what I would do to finish here is I would cross multiply. So this equation here is just the blue stuff. Let's cross multiply that. So we end up with 0.05x plus 255 equals 0.12. And do the same thing with the other equation where you cross multiply. So you have these two equations now. And now you can expand that out and deal with it as necessary. So there's no pretty way to do this. One thing that I might do here is I could multiply everybody by 100. I could take this equation and multiply everybody by 100. So if we do that here, we get 5x plus 255 with two zeros equals 12. And over here, I could do the same thing. So that'd be 8x plus 100y equals 15x plus y plus 255. And then after some steps here, the first one would become negative 7x minus 12y equals minus 22440. I'm going to make those all positive. So this is not like a quick thing. This is going to take some time and some writing. But once you get that equation, that's done. And you could repeat that one for the second one here and get an equation that looks like this. Negative 7x plus 85y equals 3825. And then you can use elimination, substitution, Cramer's rule, etc. to solve. I'm going to leave that to you as an exercise. Full solution is available on Blackboard after you when you write your quiz today. You should get x is approximately the nearest pounds, 2742, and y is approximately 271 pounds. It is definitely a long and nasty question, Khalid. But in all fairness, I took this from a Reddit chat that was absolutely obscene. Just so it was like, what is the hardest mixing question, please? And that's the one that I found. I'm sure there's other ones that are worse, and this is only limited to 2 variables. So there's ones that are even worse that have more than 2 variables. If you encounter a question like this that had more than 2 variables, I would at that point I would probably use technology. Surprisingly, Yazan, there is. I can't really give you a reference or a web URL for them. I did a Google search that took me into Reddit, that took me into that. So that was kind of like going down the rabbit's hole of math. So that was the process that resulted in me this. I remember it distinctly though. It was the middle of the summer. It was actually last summer, yes. And I was bored, and I was like, I need to make a hard math question for my students in the fall for the linear systems chapter, and I want something that's going to challenge them and have some level of technology involving construction, etc. So that's how I ended up Googling this stuff and found this. Yeah, definitely a marathon, Mason. Definitely a marathon. My solution is not much more pretty on Blackboard, but on Blackboard, I'll just show you my paper on my camera. I show you all the steps, okay? You know all the steps where I put these vertical dots here. These vertical dots here are not like 2 seconds. They're 3 or 4 lines of writing, and I go through all those lines of writing. So if you're like, how did I go from there to there? That wasn't 2 seconds. I expanded it. I put all the x's and the y terms on one side, eventually to make it look like something structured. But if you notice here, this one turns out really nice. You got 7x and you have negative 7x. So for this question, I would use elimination because I could add those 2 equations together. Because I ran out of space here, I don't want to do that on this page, but maybe what I can do is this. Let's call that equation 1, and let's call that equation 2. And then what I'll do is I'll put another text box over here and say eliminate x by adding 1 and 2 together. And then you would end up with what? 97y equals whatever that is. I don't know my calculator. Let me just get my calculator here, Andy. Two six two six five. And if I divide by 97, hopefully that's the answer, 271, yeah.